All right, guys, this is the first time I'm trying this through YouTube. I'm trying to go ahead and do a live stream. That way it's one less thing I have to worry about, an extra step or anything like that. But tomorrow, or yeah, well, I guess there's no reason for tomorrow. Uh, so today we're talking about ratios to rates. Okay, the first half of the lesson module we talked about ratios. We talked about ratio tables, ratio diagrams, the ratio number lines, double number lines. We talked about tape diagrams. But here's the big catch. Okay, something that we struggled on at the beginning, based on your test, is something that's going to be a requirement for us to be able to get through this, and that's going to be simply just equivalent ratios. Okay, we're gonna have to be able to understand equivalent ratios in order for us to be able to get to what we're doing next. Um, so if you have questions, maybe you have them ready for class on Friday so we can make sure that we are ready to go and we are prepared. All right, so what we're going to be talking about today is ratios being able to be transformed to rates and unit rates. Now let's go ahead and make sure we talk about this word right here, transformed. Okay, I don't know how many of y'all are familiar with the movies. You had Transformer movies, and these were all these Decepticons and the Autobots, and they are all able to change from vehicles and airplanes to robots, and they were called the Transformers. All right. So to transform something is to change, all right, from one form to another. And that's what we're going to be working on. We're going to be transforming ratios into rates and unit rates. Okay. Now, real quick, what I want you to know about is we had these definitions in class, but I want to make sure we hit on them again. We are talking about, okay, rates, all right, versus unit rates. Okay. Now, rates are a comparison of two different objects. Okay. Normally, they're going to be a comparison of different measurements, like miles per gallon, pounds per I don't know, pounds per ounce or something like that. I don't know. I'm just coming up with some baloney right here. I'm sorry. What it should have been was cost per ounce. Okay, something like that. Okay, those are different types of rates. An example of that is, 25 apples per 5 bushels. Okay, a comparison of apples to bushels, a bunch of numbers. Okay, whereas a unit rate is a comparison of two different measurements that have a denominator of one. And that's the key thing I want to make sure we hit. It will have a denominator of one. Okay, like 45 miles per hour, uh, 22 miles per gallon, or 3.99 per pound. Okay, each of these have a single unit. Okay, and that's what the goal is. We're talking about single units here. Okay, now let's look at example number 1, introduction to rates and unit rates. Diet Cola was on sale last week. It cost $10 for every 4 packs of Diet Cola. Okay, so how much do 2 packs of Diet Cola cost? Okay, so what we're going to do here is, first we're going to set up 2 fractions. Okay, 2 fractions here. The first fraction is going to consist of how much it cost for 4 packs of Diet Cola. Okay, so our first fraction is going to be cost over number of packs. Okay, that's our fraction. The cost over the number of packs. So our dollars for 4 packs. Once it's defined is how much does it cost for 2 packs. Okay. Well, let's take a look at this. All right. All we're doing is taking the number of packs we have and cutting them in half. So we're dividing by 2. So if we do the same thing to the cost and divide by 2, how much do we have? Correct. It's $5. So it is going to be $5 per pack. Okay. Now look at question number B. You're going to see a little bit of movement here. Okay. Question number B. How much does 1 pack of Diet Cola cost? Okay. So now we know that it's going to be, so we're still going to be looking at a cost per number situation here. Okay. We had $10 for 4 packs. We had $5 for 2 packs. We want to know how much it costs for 1 pack. So if you notice, our units on the bottom are getting smaller and they're being cut in half each time. 4 divided by 2 got us 2. 2 divided by 2 gets us 1. 10 divided by 2 gets us 5. 5 divided by 2 gets us, correct, $2.50 per pack. Okay, that's what our cost is. It cost us $2.50 per pack of Diet Cola. Okay, now obviously this was about 15 years ago because getting $2.50 for a 12-pack of Coke is just almost impossible now. Okay, all right, now it's like 3 for, you know, get $12 for 3, so it's like $4 a pack. Now it's like, oh my goodness gracious. I know, I just showed my age. All right. So, all right, so we are looking at part of the exploratory challenge. Okay. Let me bring this down a little bit. There we go. All right, so sorry, guys. I'm trying to make sure it fits. There we go. So we have 4 football fans took turns driving the distance from New York to Oklahoma to see a big game. Each driver set the cruise control during his or her portion of the trip, enabling him or her to travel at a constant speed. The group changed drivers each time they stopped for gas and recorded their driving times and distances in the table below. We got Andre here, who goes 208 miles and does it in 4 hours. Mateo is 456 miles in 8 hours. Janae goes 300 miles in 6 hours. Grayson goes 265 miles in 5 hours. Okay. Now, according to this, it says use the given table to answer the questions below. All right, so I'm going to come up just a hair here. All right, because we no longer need the question. All right, we just need the table. Woo. All right, so question number 1 is asking us what 2 quantities are being compared. Okay, is it fan and the distant miles traveled, or is it the distant miles traveled to the time in hours? Okay, that's correct. We don't care about the fan. All right, we don't care who's driving. What we care about is the comparison to distance and time. Okay, distance to time. That's our ratios. Okay, distance to time. Now, question number 2 is asking us what is the ratio of the 2 quantities for Andre's portion of the trip? Okay, what is the associated rate? So we come back up here and we take a look at Andre. Andre travels 208 miles in 4 hours. So there's his ratio. His distance traveled is 208 miles to the number of hours it took was 4. 208 miles to 4 hours. Now his rates, okay, this is just a ratio, 208 to 4, okay? There's no unit of measurements here. That's what's the difference between a ratio and a rate. A ratio doesn't have 2 different measures, okay? Whereas a rate does. We're comparing 2 different measurements. So in this case here, our rate is 208 miles, okay, per 4 hours. And if you notice, another big key thing here about difference between ratio and rate is that key word right there. If you notice, I keep on saying per. Per is important. You're going to see per a lot, especially when we get to percents. But right now, that is a big key difference between ratios and rates. We use the word per a lot, okay? Now, we need to sit there and we need to look at question 3, okay? Answer the same 2 questions in part 2 for the other 3 drivers. Mateo's rate, okay, I'm sorry, Mateo's ratio. Go back and look at the table. His ratio is 456 to 8. Janae's ratio was 300 to 6. Grayson's ratio was going to be 265 to 5. Okay. Now we need to write our rates. So all we're going to do is still take our numbers, but we're going to make sure we're putting the quantity or the measurements behind it. Okay. 456 miles per 8 hours. All right. 300 miles per 6 hours. 265 miles per 5 hours. Okay. Now, this is going to be a bonus question. Okay. And I want you to listen very carefully. I'll repeat myself at the end. Classes start at 8:15 in the morning. Okay. The first student to bring me a post-it note, stressing this, a post-it note, okay, with the name of the person that was driving the fastest, all right, who was driving the fastest will get 20 bonus points on their test that we just had. I will add 20 points to your grade. So again, I want a post-it note with the name of the person who was driving the fastest, and then I want your name on the back of the post-it note. All right. So you're hearing me. Just remember that. I'm not going to repeat myself, except for at the end of the video where I might repeat myself. All right. So we are done with lesson 16. We're going to go ahead and move on to lesson 17, guys. All right. So I'm going to pull back a little bit here. So we are looking at lesson 17. We're still continuing from rates to ratios. Okay. So you now have seen how to write a rate. Okay. How to take a ratio and write it as a rate. So now we're going to continue practicing that. We want to write the unit rate and we want to practice the rate. Okay. Now let's take a look at this. Given a rate, you can calculate the unit rate in associated ratios. Recognize that all ratios associated with a given rate are equivalent because they have the same value. Okay. Key phrase there. All right. So make sure you're sitting and remember, just understanding this. Recognize that all ratios associated with a given rate are equivalent because they have the same value. Same value. That is important. All right. So we're looking at example 1. Write each ratio as a rate. The ratio of miles to the number of hours is 434 to 7. Okay. The ratio of miles to the number of hours is 434 to 7. Okay. Well, let's write ourselves a rate. Okay. So we've got 434 miles, okay, over 7 hours. All right. There's our rate. 434 miles per hour. Now, I don't like this part because it does kind of get a little crazy. Okay. Because to me, this is a rate. Okay. A unit rate, you get down to a denominator of 1. But the way that the book has got this set up, and we're going to work on this and we're going to practice this a lot together. Okay. So just be hesitant about this. All right. And you remember we talked about this in class, so I want you just to remind you of this. Okay. So this right here to me is considered a rate. But what the book is asking us to do is they're asking us to simplify this. Okay. So they want us to take 434 and simplify it. All right. So we got to take a look at this. So we're going to take 434 and we're going to divide it by 7, see what we get. 7 goes into 4, 0 times. 7 goes into 43 times. 6 times 7 is 42. You subtract, you get 1. You drop the 4 down. 7 goes into 14 2 times. Okay, 2 times 7 is 14. 14 minus 14 is 0. You get 0. You're done. You checked. All right. So what this is actually going to say is, to simplify this, it would be 62 over 1 miles per, and sometimes they'll use the word per, or they'll use a hash like that, per hour. Okay. It's the reason why I don't like it. The other way they can ask you to write this is they could write it as 434 over 7 miles per hour. Okay, that's another way they could ask you to write it. Okay. Either way, see, to me, this is what I would classify as a unit rate because you have a denominator of 1. This here, again, is what I would classify as a rate because you still have that denominator of 7. All right. Look at B. The ratio of the number of laps to the number of minutes is 5:4. Okay. So we've got 5 laps to 4 minutes. Now, if I was going to rewrite this, like I said, just rewrite it to where I have laps per minute, I would just sit there and say, okay, so 5/4 laps per minute. Okay. Just take your rate and then leave that alone, just leave it 5/4, and then take your laps per minute. That to me is acceptable as well. Okay. So just a couple of example 2, because example 2, it looks like we're going to go a little bit deeper. So complete the model below using the ratio from example 1, part B. So our ratio was 5:4. Whoop, wrote too hard. 5:4. Okay. Now it wants our unit rate. Okay. It wants our rate. It wants the two of them. Okay. Now, like I said, to me, your rate is just going to be your two numbers inside a fraction form. So 5/4 laps per minute. Our unit rate is when we have a denominator of 1. So we have to take 5 and divide it by 4. And when you do that, you get 1.25 over 1. That's your unit rate. Okay. I know what you're asking. You're like, Mr. Hay, what are you talking about? How'd you get that? All right. So 4 goes into 5 one time. 1 times 4 is 4. You subtract, you get 1. You put in a decimal. Make sure you put a decimal up here. We add a 0. Drop the 0 down. 4 can go into 10 2 times. 2 times 4, that's 8. Subtract, you get 2. All right. Got a little bit here. All right. Now we got to add another 0 and you bring it down. How many times can 4 go into 20? 5 times. 5 times 4, 20. 20 minus 20 is 0. You get 0, so that's your answer, 1.25. Right. Like I said, if you have questions, you just bring them to me tomorrow morning, and we'll go over these again to help you out, okay? All right, so let's look at numeral 3, okay? So we got Dave here. He can clean pools at a constant rate of 3/5 pools per hour, okay? So what's the ratio of the number of pools to the number of hours? Now, remember, when you've got a unit rate, okay, all you've got to do is rewrite your unit rate or write your rate. I mean, this is a unit rate. I like this. 3/5 pools per hour. That's the unit rate. Okay. So we're going to take 3/5 and we're going to leave it alone. Okay. Now we follow the order of the actual rate part. Okay. So we put pools at the top. We put hours at the bottom. Okay. So now it's asking us, what is the ratio of the number of pools to the number of hours? It's 3 pools to 5 hours. Okay. Now it's asking us, how many pools can Dave clean in 10 hours? Well, if he can clean 3 pools in 5 hours, I want to know how many pools I can clean in 10 hours. All right. What do I do to go from 5 to 10? Correct. I multiply by 2. Multiply the numerator by 2. What's 3 times 2? 6. He can clean 6 pools in 10 hours. Okay. Now I go down to C. How long does it take Dave to clean 15 pools? Again, we already know his rate. We know he can clean 3 pools in 5 hours. 3 pools, 5 hours. Now I want to know how many pulls it takes for him to clean in. Oh, my bad. It says not 15 hours. It's saying 15 pulls. See, I almost made a mistake. So now we got 15 pulls at the top. So what we don't know is how many hours it would take for him to clean 15 pulls. Okay. So again, the question is, what do I do to 3 to get 15? Okay. And I multiply by 5. 3 times 5 equals 15. So then I multiply the denominator by 5. 5 times 5 is 25. So it's 25 hours to clean all them poles. Okay. All them poles in 25 hours. Okay. Now, let's go to the last question here. Okay. We almost done, guys. Okay. We just down to question number 6 here. Okay. Going to move back a little bit. I'm going to fiddle around my camera. All right. So, the corner store here sells apples. They sell apples at a rate of $1.25 per apple. So what's the ratio of the amount of dollars to the number of apples? All right, well, we got $1.25, okay? Now, the problem is we don't want to deal with decimals when we're talking about ratios, okay? So I got to find a way to convert $1.25 to a whole number. So this is what I'm thinking, okay? I'm looking at that $1.25 and I'm wondering, what's that as a fraction, okay? And I'm thinking to myself, well, I know 25 cents is 1/4 out of 4, and that's 1/4 out of $1. So that would be 1 1/4, okay? Now, that's a mixed number right there. And I know how to sit there and get a mixed number into an improper fraction. Take the denominator, multiply it by the number in the front, which would be 4 times 1. Okay. And then I add the number in the numerator, and that's all over the denominator. So 4 times 1 is 4. 4 plus 1 is 5. So now you get 5 over 4. Okay. So the ratio is $5 to 4 apples. There's your ratio. $5 to 4 apples. Now, I know you guys had some questions about this in class, but I'm just showing it to you again. Again, you got questions? Ask me tomorrow in class and we will address it. Okay. Now, we look at B, Akia. Akia is only able to spend $10 on apples. How many apples can she buy? Well, we know that she can spend $5 on 4 apples. That's what our ratio is telling us. We get $5 for 4 apples. Okay. So now if I want to spend $10, how many apples am I going to get for $10? Well, I look at my numerator and I say 5 times what's going to get me 10? It's right. 5 times 2 equals 10. So then I take the denominator and I multiply it by 2. So what's 4 times 2? That'd be 8. She can get 8 apples. Okay. So she's able to buy 8 apples. Now, the other thing you could have done, a little bit harder to do, you could have taken $10 and divided it by 1.25. Just a little bit harder to do because you got to deal with that decimal. This, we don't have any decimals to deal with. So we're able to avoid that problem. Now, let's go ahead and take a look at part C here. Okay. Good old Christian here. Christian has $6 in his wallet and wants to spend it on apples. How many apples can Christian buy? Okay, $6 in his wallet, wants to spend it on apples. Well, we know that he's able to get, if he spends $5, he's able to get 4 apples. Okay. But problem is he's got $6 and he doesn't know how many apples. Okay. Now, here's where I'm going to teach you a little bit of something that we haven't gotten to yet. Okay. I'm going to teach you about proportions. Just briefly, okay? So proportions, what we're going to do is we're going to do that butterfly method, okay? We're going to multiply a denominator times a numerator and then another denominator times a numerator, okay? Now, 5 times x. X is a variable. X is going to stand for, this is what stands for our number of apples, okay? That's what it stands for, is the number of apples, all right? So 5 times an unknown number of apples is just going to be 5 times x, okay? 6 times 4, that's going to be $24. Or 24, let's make it 24, okay? So that's our cross multiply part, okay? We cross multiply. Now we got this one last thing we got to do, okay? Because what we're saying is that 5 times whatever this x is going to equal to 24. So I got to figure out what that x equals, okay? This is where I like to say we're going to do is cross multiply, all right, and divide, okay? What you're going to divide is the number with that variable. So we're going to divide both sides by 5, okay? 5 divided by 5 we know is 1. So we get x equals, and then we're going to take 24 and divide it by 5. So I'm going to come over here, 24 divided by 5. 5 can't go into 2. How many times can 5 go into 24? That's right, 4 times. 4 times 5 is 20. We subtract. It's 4. Okay? We add ourselves a decimal, drop it right on down here, get that 0, put that decimal up there, and we drop the 0 down here. So 5 going to 40 8 times. So we get x equals 4.8 apples. Now, here's my question to you. Can you go into a grocery store and say, hey, I only want 8/10 of an apple? No, you can't. You can't go into a grocery store and ask for 8/10 of an apple. They look at you like you're crazy. You have to buy the whole apple. So the question is, can Christian only buy 4 apples? Or is he able to buy 5 apples? Well, according to his $6, he can't get to 5. He's too short. Okay. So he has to round down. He can only afford to get 4 apples worth. He can only get 4 apples for $6. I know it sucks, but he can't get 8/10 of an apple. He wants another apple. He's got to have 25 cents. Yeah, what do you mean, Mr. Hale? Well, okay, let's take a look at something here. We know, and I'm going to show you another way, so you can sit there and be like, oh, man, that's so much easy, Mr. Hale. All right. That is the proportion method, okay? The easy method, all right, to find this out, we know that Christian, okay, has $6. We know that $5 buys you 4 apples. We also know, based on the problem at the very beginning, that the corner store sells at a rate of $1.25 per apple. So if we take $1.25 and add 1 more apple in, we find out that you need $6.25 to get 5 apples. Does Christian have $6.25? No, he doesn't. So he can't afford that extra apple. That extra apple is completely unavailable to him. He can only afford to buy 4 apples because he's got $5. Oh, excuse me, he's got $6, so he can only afford to buy 4 apples. All right? And that's the end. That's what the first 2 lessons that we are after your test. So if you got questions, you got things you want to ask me, by all means, ask them away. Okay? But I'm telling you, do your homework. Do your Eagle warm-ups. Do your Eagle cool-downs. We'll get there. Piece by piece, bit by bit, we'll get there, I promise. We'll be good. All right, guys, you have a good night, and I'll see you tomorrow morning in class, okay?